So in the previous video, I introduced you to Helm. Every Kubernetes engineer does need to be at least a little bit familiar with Helm. I'm not a particular heavy user of Helm, but we are going to use it on this course to install Prometheus and Grafana to give us a monitoring solution. So hopefully by this point you've got Helm configured and it's running and you're able to issue commands like helm ls. Now I'm here on the GitHub repository for the Helm charts and you'll find it at the URL you can see here. As you noticed previously, there is a folder for Incubator which consists of a huge number of projects that are kind of currently still being developed, and under Stable are the stable projects managed by Helm. I can't remember if I mentioned now, but each of these projects is called a chart. It's really nothing more complicated than a set of YAML files. Now, to get a full monitoring system, the problem is we need to combine a lot of different components. I've mentioned that we are going to be working, I'll scroll a long way down here. There is here a folder for Prometheus, so I could install that chart. I'm sure there's also a folder for Grafana, so I could install that chart. But there are other components involved in a monitoring system, such as alerting, which we'll be looking at in a few videos' time. So I hope you're getting a feeling now that to get a full monitoring system, we do need to bring a lot of different components together. Also, the other problem is we would have to configure Prometheus to tell it what kind of metrics that we are wanting to monitor, such as CPU usage. And for Grafana, as I mentioned when we first saw Grafana, Grafana can support lots and lots and lots of different data sources. So we would have to configure everything so that it is hooked up to Prometheus. Now, all of that is a lot of work. And for that reason, scrolling back down, what we're going to use on this course is not actually Prometheus. Instead, it's a project called Prometheus Operator right here. Let's click through to Prometheus Operator. Now, this is a project which has been built by an organization called CoreOS, and they have basically done exactly what I've just described. They've pulled together Prometheus and Alert Manager and Grafana, quite a few other components as well. They've integrated them, and they've set up a configuration for Kubernetes which will out of the box give a complete monitoring solution. Now, I'm afraid on this course I can't go into the deep advanced concepts in Prometheus or Prometheus Operator, but I hope this is going to serve as a really good starting point if you want to use this on projects. Now, this is an update to the course because on the original version of this training course, unfortunately, Prometheus Operator was not a stable chart. In fact, you had to go across to the CoreOS site to download lots of different charts, and it was quite a fiddly process to install. But I'm re-recording this video now because Prometheus Operator is now a standard, stable chart. And for that reason, if I go a little further down, there is a user guide here, and if you want to do any tuning of this, you will need to use this user guide. But the really good news is to install using Helm is a very simple command. It's just helm install stable / Prometheus Operator. Although I would recommend going a little further down that we do give the release a name. If not, your release will be given an automatically generated name, and that will appear in all of the pods and the services, and it will look quite ugly. So we can install then using helm install. As suggested, we'll use the name monitoring. But also while we're here, it would be well worth installing all of the monitoring resources into their own namespace. And I don't think it mentioned that on the user guide, but we can do that with dash namespace. I think we'll use monitoring for the namespace as well. And then it's stable / Prometheus -operator. If you've got that command right, it will freeze for a short while it does some thinking. And then eventually it will give you a report giving you a full list of all of the objects it's created. As you can see, there's quite a lot there. but we could also do a kubectl get all on the -n monitoring namespace. And yes, very nearly a screen full of objects there. So the Grafana service is definitely the one that we want to be looking at, and that's what we'll be doing in the next video. But before we do that, I would like to show you that there is a front end for Prometheus as well. So remember Prometheus, and there are actually 4 or 5 services here which seem to relate to Prometheus in some way. Prometheus is the engine underneath all of this, which is responsible for scraping all of the metrics and gathering together all of the data that's needed for monitoring. And Grafana is just the nice front end. I would like to have a very quick look at Prometheus to show you what it's actually like. And to do that, now is a bit bewildering, this long list of different services. Actually, the one that we want to work with to see the basic Prometheus is this one here. Now be careful to identify it correctly. It's the one that's called Monitoring Prometheus for Operator -Prometheus. Don't get confused and look at the one above, which is -Operator, like I did when I was practicing for recording these sessions. I spent quite a long time trying to work out why I wasn't seeing any results. So make sure you choose the correct one here. Now in its default configuration, it's a service of type cluster IP, which you might remember from earlier means that that service is not currently accessible from outside of the cluster. It's just internally accessible. There are several ways of opening up this service to the outside world, and as we go through this course, I will show you some different techniques for accessing these internal services. For now, I want to do things in the quickest possible way so that we can get on. So what we'll do is we'll switch this cluster IP and convert it into a load balancer. Now bear in mind that does mean we're going to incur some costs on AWS. We won't be here long before we tear the entire cluster down, so it won't cost you much money, but that might be worth bearing in mind if you're doing this on a real project. There are some other more complicated ways of exposing the service, which we will be covering later in the course. Now, I don't think I've shown you at any point how to modify an existing Kubernetes object. This service has already been deployed. But what we can do is use the kubectl edit command, and we will need to remember to do -n for the namespace of monitoring. And then if we plug in, and be very careful here to pick the right one, the service monitoring Prometheus Prometheus, just paste that in. And now we will get an editor, and the idea is we can change, in theory, any of these values, save the file, and then those changes will be applied on the fly. So the plan is we'll change this cluster IP for a load balancer. Now the default editor is VI, or the Vim editor, which I know many of you will be familiar with, but it is quite a tricky editor to work with, and I really don't have time to cover the basics of Vim here. So if you're not familiar and comfortable with VI, you can change the editor. So if you want to, you can exit this editor by pressing the colon key, and you should see the colon appearing at the bottom of your screen here. I hope that's showing okay on the video. And then a lowercase q, and then return, and you're back to safety. If you'd rather use a friendly editor, you can export the editor environment variable, that's all in capitals, and set that equal to something friendlier like nano. We're using Amazon Linux here, so I know that nano is already installed. So if I repeat now the edit command, yeah, we are now in the friendlier nano editor. So whichever editor you're using, what you need to do is go down to the type line and remove cluster IP and replace that with load balancer. Now it's quite odd the way this editing works. What will happen if you've got an error in your edits? Let me fake an edit. I'll put a load of garbage in there, so of course this is now not valid YAML. If I save the file, and you do that in Nano with Control-O to write out the file, this is going to be a temporary file, hit enter, and then Control-X, which should exit the editor, but I've actually been bounced straight back into the editor. And that's confusing at first until you realize that the comments up here will contain any errors. So it's telling me line 19, invalid character A, which was the start of my garbage. So if I remove that garbage with, I think it's Control K in Nano, and it is, I think now I should be able to repeat the process of Control O, Enter, and Control X. And yeah, I'm now safely back onto the command line. I'll now repeat kubectl get all on monitoring. Remember previously it was cluster IP. Now it's been switched for a load balancer. I can take now a copy of the name of that load balancer. Now this is a difference on newer versions of kubectl. It does actually show you the full name of the load balancer without having to describe it, which is a very useful upgrade. Take a copy of that, but note that the port number that we need to use on this load balancer is port 9090. In a browser then, paste in the full domain name of that load balancer, followed by :9090. I'm sure you're familiar with this already, but for a while that load balancer won't be available, and that's just while it's doing its registration checks. Give it a few minutes. So that took about 4 or 5 minutes for me, but I am now seeing the Prometheus front end. As you can immediately see, the front end for Prometheus is very basic indeed. We're going to put Grafana on top of this to give it a much nicer and more usable look and feel. But just to give you an idea of what Prometheus is doing, it has been pre-configured. We don't need to do any further work on this to gather quite a large set of metrics, and we can find those metrics by dropping down this box here. I mean, there's hundreds of them. Now, if you're any kind of Linux system administrator, then you might be familiar with many of these labels. Let me see if I can find something that I do recognize. Okay, so for example, one of the metrics that Prometheus is pre-configured with this installation to gather is the node load, which is going to be the CPU usage of every node in our cluster. And there are actually 3 different configurations of that metric. There's node load 1, node load 5, and node load 15. And these are just those values averaged out over a period of minutes. So node load 15, for example, is the load on a node averaged out over the last 15 minutes. And that's a pretty useful metric because that smooths out any temporary spikes in CPU load. For example, when you've just first started a node, it's often overloaded because you're starting up lots of pods. So if I select any of these metrics, but I'll go for node load 15, I can then click on execute. And it's going to give me the current values that Prometheus is tracking for that metric. So I actually have 4 results, and that's because there are 4 nodes in the cluster. There's 1 master and 3 workers. And, you know, it's not very readable, any of this, but I can see, for example, that on one of my nodes, I don't know whether it's a master or a worker or whatever, I need to check its IP address to find out, but I can see it's currently loaded at, I think that is 17%. So not very pretty, but we can click on the graph link here, which is potentially a bit nicer, I suppose. That's giving us the 4 values in different colors tracked back over time. So the front end here is a very basic front end. I don't think it's intended to be used in production, really. The idea is that we plug on top of this a much nicer user interface. That's already been done for us in Prometheus Operator. We've got Grafana, and we'll explore Grafana in the next video.